Welcome back, geometry students, to section 7.1. We're talking about extended ratios in this part 2 video. What is an extended ratio? It's simply a comparison of three or more things. A comparison of three or more things. And things is pretty specific, but we'll get a sense of what we're talking about in this example. The extended ratio of length of a fishing boat, a speedboat, and a yacht is, now fishing boats, we're not talking about those professional ones that go into deep ocean. We're talking about those little ones you take on a lake. Okay, so the length. If we consider our average fishing boat, maybe our average, let's just talk about the lengths here. Maybe our average fishing boat is what, 10 feet? Okay, a real small little rowboat or something like that. Speedboat probably is somewhere around 20 feet. And then we have yacht with a minimum of probably about 30 feet. Okay, this is just a rough average. This is in no way research based. This is just to get a sense of extended ratios. Okay, so don't be calling me out in the comments. So now we can say the ratio of F to S to Y. So here we have, we're going to do F to S to Y. Now, we could put 10 to 20 to 30, or we could reduce it, okay? We could say, and actually, we'll leave it like this. What I want to kind of emphasize in this section is that we can reduce these ratios, okay? So instead of writing 10 to 20 to 30, we can divide all of them by 10 and get 1 to 2 to 3, okay? Now between those, that 1 to 2 to 3 ratio, we could write the ratio of F to S as 1 to 2. Okay, that means what? That means the speedboat is twice as big as the fishing boat. For every 1 foot the fishing boat is, the speedboat is 2 feet. Okay, and something else to consider, let's say we have the original 10 to 20 feet. Again, we can reduce ratios to be in smallest terms. All right, moving on to F to Y, that would be 1 to 3. Here we're just going from our F to Y, 1 to 3. You could put 10 to 30 and then reduce if you want, and then 2 to 3. Okay, the closer these numbers are together, the closer they are in similar size. The further these numbers are apart, the further they are in size to each other. Just something to keep in mind. Now we're going to talk about some specific properties we use when we have proportions. So we're going to go ahead and start right now. Cross products property. If A over B equals C over D, okay, then what? We can say, let me change the color here, then we can say BC, or B times C, is equal to A times D. Keep in mind that B cannot be equal to 0 and D cannot be equal to 0. Why not? Well, if these two numbers are 0, then we're going to be dividing by 0 and we're going to have undefined solutions, and we can't have that. Okay, so B cannot be equal to 0, D cannot be equal to 0. Now, let's test it out. Is 1 over 2 equal to 4 over 8? One way we can check to see if this is true is we can cross multiply. Okay. We already do know that 1/2 is the same thing as 4 over 8 because we can reduce 4 over 8 to be 1/2. So we do 2 times 4 on the left. We're going to do 1 times 8 on the right. And we get 8 equals 8. So is 8 equal to 8? Yes, it is. So this is true. Okay, moving on. More properties of proportions. If A over B equals C over D, then it's also going to be equal to what? We can say A over C and B over D. That is one of our properties. We can put these two over each other and these two over each other, and it will also be true. Let's come up with another one. So if A over B equals C over D, as it was before, we can switch those one of the numerators with one of the denominators. So we can say that put the C there, put the B there, and then we have, is that black or is that like more of a graphite? I think it's a graphite. So we can put the A and the D there. I don't know what happened to my A there. So we can switch these, okay? So that's what we did, is we switched these two, and that is another move that you can use with proportions. These are just more of a manipulation, so if you can recognize some of the manipulation, that's okay, but you can do a lot of stuff by just, you know, using your rule of fractions by multiplying by b to both sides or dividing by c to both sides. This just moves you can do in fractions in general. Okay, and our last one, if a over b equals c over d, then we can say that, let me put my a and c over here. We're going to put plus and plus. Okay, we can say that, I think that's a different color, orange. We can say that, oh, that's red. Oh my goodness. Working my colors. A plus b over b is going to be equal to c plus d over d. Okay, so we can add b in the top and add d in the top for both of those, and the value will not change. Okay, so just some quick proportion tips for you, and now we can go ahead and get to some examples. It says solve for x for these. Okay, solve for x. All right, so let's go ahead and do that. The first one, fairly simple. What we're going to do is we're simply going to cross multiply. Here we have 6 over x and 5 over 4. Anytime you see this equal sign, this is a good indication that you can just cross multiply. It'll make it easier. So we have 6 times 4 on the left equals 5 times x on the right. So we have 24 equals 5x. Divide by 5, divide by 5. Okay, and we can just leave it as an improper fraction. Don't worry about dividing that out. That's good. That's good for me. But if you're deeply curious, it's about, I think it's 4.8, because 25 over 5 is 5, so that should be 4.8. Okay, moving on to b. Here we can also, we're trying to solve for x, we're trying to get the x by itself. Okay, so we can cross multiply here. We have 3, and now, this is what I want you guys to know. If you have addition or subtraction and you're multiplying, make sure to put that in parentheses, equals 9y. Okay, we're going to distribute. We get 3x plus 12 equals 9y. Now, I know what you're thinking. Whoa, there's a y in there. What do we do with that? Well, if we're solving for x, we can still solve for x. We just try to get everything by itself. We just move everything else over. So we have 3x equals 9y minus 12. Don't combine the 9y and the 12. They're not like terms. Then we're going to divide by 3. And when we divide by 3, really what we need to do is we need to do 9y divided by 3 minus 12 over 3. You can divide 3 by both those terms. So you get x equals 3y minus 4. And that's your answer, okay? You're going to have it in terms of y because we only have one equation with two variables, so you're going to have one in terms of the other. Finally, example 4, in the diagram, x over 6 equals y over 7. What ratio is equal to x over y? Okay, now, we can do some equation manipulation to get x and y over each other with this. This is what I was talking about earlier. Let me just show you what that means, and then I'm going to show you the quick way, okay? So if you want to see the quick way, just maybe skip ahead until you get to this quick way there. Once you see me start writing here, then you can just resume playing. That's just a heads up, a courtesy, will you? All right, now, first thing we notice is we don't have the x over the y. We want that y to be here instead of that 6. So let me show you two different ways, okay? So first, what we can do is we can multiply both sides by 6. That's to get rid of the 6. So we have x equals 6y over 7. Now, we want this y to be over here, right? So what we can do is we can multiply both sides by 1 over y. Okay? And what that will do is it'll cross off the y's on the right, leaving us 6 over 7. And on the left, we're going to have x times 1 over y, x over y. So we get 6 over 7 with that ratio. Okay? That's one way. The other way to do it, as we talked about earlier, is to use this method right here where we did the good old-fashioned switcheroo. Okay? So here we could switcheroo. We could switch this for this guy, move him there, and we just get x over y equals 6 over 7 after he teleports over there. Okay? That was one of the properties we learned. The quickest way, and I think this is the most beneficial, is if we know that x to 6 is equal to, let me get a different color here, y to 7, okay, we can also say x to y is going to be similar to 6 to 7, okay, because we have triangles being situated here. If these triangles are similar, low battery, well, I'm almost done anyway, then we can say those are also similar, okay. It has to be similar though. These are similar proportions. So we can just say, the quick way, x over y, oops, let me change my colors. X over y is going to be equal to 6 over 7, because before we are comparing the short side, we are comparing the short side to the long side. Again, this is the short side for the bottom side to the long side. Okay, this is a short segment, and this is a longer segment. That's what I'm saying. And then we just changed it. Instead of going short to long, we're going to compare long to long, short to short, and that's what that is. This is the short side. This is the long side. Oh, nope. This is the short side. And we're comparing the two long sides to each other, long to long. You can do that as long as you're consistent on both sides of the equal sign. So here's the equal sign. We just want to make sure it's consistent. Or another way to think of it is we compared the left side to the left side and the right side to the right side. This is the right side, this is the right side, this is the left side and left side. Why is that weekly report coming up now? How rude. Well, that's all we have here. Hopefully you guys stuck with it. Hope you enjoyed this video. Make sure to check out our next video on similarity. This is Don Bosco, in case you're wondering who this guy is. He's kind of a big deal at our school. But anyway, hope you enjoyed this video. Thanks for watching. Tune in next time to Wes Explains Best.